Now we are going to look at some linear functions. By looking at these linear functions, we're going to be able to figure out the slope, the behavior, and the vertical intercept. Each of these functions is named something different, so let's start and take a look. Now, anything that is attached to the input is going to be our slope. So in this case, our slope is -2 because it is the number that is attached to the x. Negative slopes decrease. Positive slopes increase. So this guy is decreasing. How do we find the vertical intercept? The vertical intercept, if we were looking at a coordinate plane, if we're looking at a line that is decreasing, crossing, the vertical intercept is where it crosses the y-axis. So in order to find the vertical intercept, x has to be 0. If x is 0, all we're left with is this number that's not attached to the x. So this number that's not attached to the x will always be the y value in your vertical intercept. So the vertical intercept is always going to start with a 0, and it's going to be the y value that is left over when you plug x equal to 0. Looking at letter B, what is attached to our input? Our input is n. There's nothing there. But you can kind of imagine that there's a 1, right? There's always a 1 attached to a number. So it's a minus. Therefore, it's a -1. We could rewrite this as -1n plus 2. So we know that the number attached to our independent variable, our input, is a -1. So the slope is -1. Because the slope is negative, it's decreasing again. And what happens if we plug 0 in for n? What are we left over? That 2. Looking at letter C, g of x, what is attached to our input? A fraction, the fraction 3/4. Because the fraction is positive, the behavior of the graph is increasing. And what is the number that is not attached to a variable? 2. So therefore, our vertical intercept is going to be 0, 2 again. Letter D is a little bit tricky. We do see our input is t. There's a 4 attached to it, so therefore the 4 is our slope. The 4 is positive, so it's increasing. But what is our vertical intercept? There's nothing over here. Well, there's always a invisible 0 added on to anything. Therefore, if we plug 0 in for t, we're going to be left with a 0. So our vertical intercept is 0, 0. F of x equals -6. There is no input. However, there's always an invisible 0 times the input. Therefore, our slope is 0. What is going on with the behavior? It's 0. It's neither positive nor negative. It's neither increasing nor decreasing. Therefore, it is constant. The vertical intercept, when x is 0, y is -6. And our last interesting example here, I'm going to do this one in red. X equals 4. So x is always going to be 4. 1, 2, 3, 4. If y is 4, x is 4. If y is -1, x is 4. X is just always 4. It's this vertical line going down. What is the slope of this vertical line? It doesn't exist. This slope does not exist. Vertical slopes cannot be calculated, and here's why. Our output, let's say here, is 4, 4. Over here, we called that 4, -1. Let's try to calculate that slope. Our outputs, 4 minus -1, over our inputs, 4 minus 4. 4 minus -1 is 4 plus 1, which is 5. 4 minus 4 is 0. We can't divide by 0. That is why our slope does not exist. The behavior is vertical. It's just a vertical line. The vertical intercept, is this ever going to cross the y-axis? No. So the vertical intercept also does not exist.